GameSci.com. GameSci.com.
Holy moly, it's time to study objects only. Objects only. Python is an object-oriented programming language. Therefore, the understanding of objects is very, very important. Now, let's do a lesson on objects only. A class is to an object. This is like that old SAT question. A class is to an object like a blueprint is to a house. What do you got to do to build a house? You need an architect to build a blueprint, which is a detailed set of instructions on how to create a house. And that's what a class is. It's a set of instructions on how to create an object. Our recipe is to a cake. What is a recipe? It's a list of ingredients and instructions, and if you get those ingredients and follow the instructions, you can make a cake. Same thing with a class. Once you set up the class, give it its variables, give it its methods, then you can make an object. Why study objects first? If a class is needed to create an object, why study objects first? Well, first of all, we've already used objects. Objects are something we've been using all along. Every variable in Python is an object, so we've been using objects. But more importantly, understanding objects will make learning classes easier. I used to start with teaching classes, and I realized the classes were more complicated than the objects, so I flipped it. We'll teach objects first, and in the next lesson we'll do classes. Objects are variables that have variables and functions. What does that mean? Objects are these conglomerates. They are composed of multi-parts, and we've been creating variables all along. You know how to create some variables. We've been writing functions all along. You know how to write some functions. Basically, all an object is a collection of variables and functions. That's it. You already know what you need to understand an object. Do you understand variables and you understand functions? You're ready to learn objects because that's what an object is built from. Let's look at this line. Hero equals Thor. We'll start with a string object. By assigning anything with double quotes, Python automatically builds a string or str object. And you can see that the data or the variable portion of a string object is going to contain the letters Thor. Objects also have functions, and when they're in objects, we call functions methods. Index, upper, more. Objects are these two-part entities. They have variables and they have functions, and these functions we're going to call methods. Here's a second way to do the same thing as I did there on the line before. Now, Python will automatically build a string object for you, but I wanted to show you something called a constructor. The str, or string class, is used to build string objects. str is the Python string type. This is what in other languages we'd call a constructor. It says build me an str object with the letters Thor in it. Str will turn anything, an int, a float, a boolean, even other objects into a string. This is just a more literal way to do what I did on the line before. But in either case, we end up with a string object containing the letters Thor. Hero is an object reference variable. What does that mean, an object reference variable? As I've explained in previous lessons, in Python, variables refer to or point to objects. You don't store thor into the hero variable. What you store in the hero variable is a reference to an object that contains the thor. Hero is a reference variable. And what I'm doing here is saying go to the hero reference variable. Now what am I going to do with the hero reference variable? The dot operator says go inside the object and access a variable or method. The way that you access the variables or methods of an object is by using the dot operator. So I drew it as an arrow over here. Go to hero, and then the dot says go inside that object. Access something inside the object. And what we're going to access inside that object is the index method. A method is just a fancy word for a function. What's the difference between a function and a method? Very little. A method is a function that's inside an object. That's all a method is. and the methods of an object define what the object does. This will get the position of the character H. Strings, just like lists, start with index 0, so the T is at position 0 of the string, and the H is in position 1. Index method will find you the position of the H, it's at position 1, and send it back to the variable. Function versus method. I know it gets a little confusing. Sometimes I call them a function, sometimes I call them a method, but let's really go into detail on what the difference between a function and a method is. Methods are functions that are part of an object. That's it. That's the big difference between a function and a method. They have more access to the object variables and must be run using a reference. As a contrast, I'm going to call the len function, L-E-N. This is the function that will return the length of something. This is not a method. Why is it not a method? First of all, it's not attached to an object. Second of all, we're not using the dot operator to access it. This is a standalone function all by itself. You pass it a string, and it will tell you how many characters are in that string. A function is just like a method, except it's not part of an object. Index is a method because it's part of this object. Len, L-E-N, is not because it is not attached to an object. It is standalone, so we call it a function. Back to methods. Let's call the upper method this time. Converts the data stored in the object to uppercase. What it really does is it returns a new object. It does not change the data in the original object. Notice that Thor here stays a mixture of upper and lowercase. What upper does is say, take my data, T-H-O-R, convert it to uppercase, and send it back to the caller. Build me a new string object containing the same data in uppercase. And you can see I assign it to the reference variable up, and up will point to the version of the string that is all in uppercase. Notice that hero did not change. The string methods will return a brand new string to you. They don't alter the current value of the string. Be object aware. The str converts anything to a string. Whenever you see this str, you are definitely dealing with a string object. The dot operator signals an object is present. Methods have parentheses. Things I want you to start spotting in the code. Whenever you see that dot operator, you've got to say, well, that must be an object reference, and the dot says go inside the object, and this here, well, that must be a method because see those parentheses? Same down here. That dot operator tells me this hero is an object reference, and upper must be a method, a function that's part of this hero object. Methods have parentheses, so if needed, you can send them parameters. You've got to start thinking about an object as this multi-part variable. Objects are variables that have variables. In addition, objects have methods. Internal functions, internal methods that will do things, usually on the data stored in the object. Read the documentation. Whenever you're dealing with a new type of object, read the documentation. For this particular object, I would Google Python string and it'll explain all about the methods that are part of the string. The other thing I'd like you to remember, they are called methods when they are part of an object. They are called functions when they're not part of an object. So index is a function inside this object. We'll call that a method. Len, or L-E-N, is a standalone function. It does not require an object to run. Therefore, we call it a function. Next up, a list object. Lists in Python are definitely objects. Just like strings are objects, lists are objects. Python's lists are objects. They just don't, quote unquote, look like objects. What do I mean by that? Well, there have been a lot of computer languages before Python. Java, C, C++, and a syntax for dealing with arrays has developed over the years that is very consistent from language to language. Python decided to make lists work like arrays do in other languages. If I want to go into a list numbers, I'll go to slot 2 or index 2 and insert a 99 at that position. This square bracket syntax, that is consistent from C to C++ to Java, and now Python uses that same syntax. When I want to extract something from a list, just like you do it from an array from another language, I use the square bracket syntax, and it said grab me the value in index 2 of the list and assign it to the variable x. Python decided to make lists look like arrays in other languages, and that's an important thing for Python to do. You want new programming languages to look at least somewhat like old programming languages, so people are familiar with them. They don't have to completely relearn everything. Python made a practical decision to use square brackets, so list access is similar to that of C, C++, and Java arrays. This is how we've always accessed arrays in other languages. This is how we'll access data in lists. However, let's be clear. Unlike C and C++, where arrays are not objects, in Python, a list is definitely 100% an object. Seems a little circular, doesn't it? But an object is a variable that has variables and methods. Let's start by creating an array of length 3 and fill it with the value 1. This syntax says I want to create an array and I want to store ones in my array, and the times 3 says store 3 ones in my object. And you can see this object has data in it. It has variables, and of course the variables of a list would be values stored in the list. I essentially created a list with 3 slots in it filled with ones, and there's my 3 slots filled with ones. Number subscript 0 equals 5. This is the standard syntax to change a list. This is what we were talking about above. Python decided to make list access look a lot like array access does in other computer languages. But note the data in the variables of the object changed. When I said put a 5 in slot 0, a 5 showed up here in the data portion of the list object. Numbers.count1. What's going on here? This is more typical of how we access an object. Numbers dot says go to the numbers reference variable. The dot says go inside of it and run the count method. Numbers is a reference variable. It points to or refers to the object. The dot says go inside the object and execute the count method. The count method looks at the data stored in the object and returns a 2. 2 occurrences of the value 1 are in the object. These methods quite often operate on the data stored in the same object. The count method simply went up here and said, I got 1, 2 occurrences of the value 1 in my object memory. Therefore, return a 2 back to the caller and assign a 2 to the count variable. Numbers.append 44. This is a consistent syntax between object-oriented programming languages. This is how I'd access an object in Java or JavaScript. This is a consistent syntax that we see across many computer programming languages, not just Python. This is very clearly saying go to this object reference numbers. The dot says go inside and run the method inside of it. Append a 44 to my data. Drew this arrow like this for a specific reason. I'm going to the numbers reference variable and the dot says go inside of it and execute a method inside the object. That's what methods do. They add, change, return data stored in the object variables, and the 44 gets tacked on to the end of the data that's stored in that same object. And using standard object-oriented syntax, I'm going to go to the reference variable numbers. The dot operator says go inside and execute an insert method. Insert at position 2 of the list. Move the other values over for 22. So the 1 and the 44 had to scoot over. Go to the reference numbers. The dot says go inside the object, and the method alters the data on the variables. Notice what all of these lines of code are doing here. They are changing or accessing this data. An object is a variable with variables and methods. What do you think the methods do? They access or modify this data right here. numbers.remove1. Again, follow the arrow, go to the numbers reference, the dot says go inside of it, and execute the remove method. Remove the first occurrence of the value 1 from the list. Note that the last three methods we have executed change this data. We appended a 44, we inserted a 22, we removed a 1. That's what methods do. They change the data stored in the object or access the data stored in the object. Count up here just accessed information stored in the object. Append, insert, and remove actually alter the data stored in the object. Numbers.sort. Call a simple sort method. The sort method puts the order in the list. Remember, list is an ordered collection of items. Data is moved from low to high. Again, that's what methods do. They move, change, return the data stored in the object. Went to the numbers reference variable. The dot says go inside the object, execute the sort method, and it put it in numerical order. Numbers.copy. As the method name implies, this will make a copy of the object. All the data and variables will be copied to a brand new object. This is a duplicate of the object that numbers points to. The 1, 5, 22, and 44 are transferred over and they occupy a new chunk of computer memory. I will take that copy that I just made and assign it to the reference variable num2. If you understand one thing, let it be that reference variables point to or refer to objects. The purpose of a reference variable is to point to or refer to an object. When I assigned the copy to num2, num2 would point to the copy of the object. There are two reference variables here, numbers, which points to the original object, and num2, which refers to or points to the copy of the object. That wraps up this slide. We have now studied in depth this string object and the list object. Let's move on. All Python variables are object references. We don't emphasize objects early in the lessons because it's a little more advanced. We want to introduce you to computer programming first. But it turns out every single variable we ever created in this class is actually an object reference, because in Python, all variables are objects. In Python, all variables are referenced to objects, but variables come in two flavors. Immutable objects, simple types like int, float, string that replace the object each time a new value is assigned, and mutable types like list, dictionary, and custom objects that keep the same object and modify the data when new values are assigned. Mutable, that sounds like fancy words. It's not that complicated when I show it to you on the screen. Score equals 100, and I'll create a variable and store 100 in it. This visualization of an int is wrong. Technically, 100 is not stored directly into the variable score. It's stored in an object that the variable score points to or refers to. I have been drawing them this way because we did not want to cover objects in the early lessons. And by the way, other languages like Java, C++, etc. do store variables this way. But Python is different. How does Python store data? Python stores data in objects. The 100 is actually stored in an object, not directly in the score variable. Score points to or refers to the int object that contains 100. This is really how Python stores values. But a big difference, what makes an int object immutable, is what happens when you assign a new value to score. Score equals 50. What happened here was, instead of changing the 100 in the old object, Python built a brand new int object to store the 50. That's what immutable means. When I change the value in score to 50, instead of just replacing the 100, Python created a brand new object and moved the reference to the new object. Objects have data. For simple types like int, float, str, Python does not allow the data in the object to change. That's what makes objects immutable. Python has something called a garbage collection process that will eventually delete this old object because we're not using it anymore. When you assign a new value to an integer variable, Python creates a brand new object and throws away the old object. It's kind of gross, but I think of this like disposable diapers. Disposable diapers are one use only. You use it once and you throw it away and start with a brand new one. And that's all that's happening here. Instead of changing the data in a int object, Python creates a brand new one and then throws away the old one. Now, before we move on to the next line of code, note that the old object that contained 100 was removed by garbage collection, freeing up the space. There used to be an object that contained 100. But when we switch to a new object with 50 in it, the old object gets collected by garbage collection, and that memory is freed up so it can be used for something else. What is it being used for? How about a string? Also note we jumped over the function definition to the next executable line of code, and we said name equals Mario. Well, in Python, all variables are objects. So what happened? It built a string object this time containing the letters Mario, and name is a reference to that string object. The str or string type is also immutable. Mario is stored in the object and the name variable points to or refers to the object. Keep in mind, if anyone tries to change the data in the object, it will create a new one instead of altering Mario. That's what immutable means. Whenever you try to change the data of an immutable object, it simply builds a new object and throws away the old one. Call the function newName and pass it the name argument. So what happens is NAM is assigned the name reference. The value of the argument is assigned to the parameter automatically under the covers by Python. Strings, ints, floats, they're all what's called pass by value, aka call by value. What that means is we're going to make a copy of the parameter. When you pass by value, nothing you can do can change the original. The variable name will contain Mario when the function returns. Pass by value says make a copy of the variable. Run the function newName and pass it the name argument. So NAM was assigned the exact same thing or the same object that name is pointing to. And you can see NAM is pointing to the string that contains Mario, just like name is pointing to the string that contains Mario. But remember, NAM is an immutable string type. Any change we try to make to NAM will not change Mario. Inside the function, we say NAM equals Duke. NAM is an immutable string. Python creates a new object and moves the reference from Mario to the new object Duke. This is the pass by value. This is the copy that I was talking about. Any changes made to the parameter will not change the original. Notice what happened here. I assigned a new value to this variable. It created its own object and left the old one alone. Therefore, it cannot change. Notice I just did a simple red line here. What I'm doing is doing a pause at this location. Pause after the function returns, but before we execute the next line of code. On return, the function's local variables are deleted. So the reference NAM will be deleted. When NAM is deleted, garbage collection will also remove the Duke object. Local variables, and parameters are local variables, disappear when the function returns. We lost our reference to this object. Well, what happens when you lose a reference to the object? Garbage collection will delete that object. But guess what stays and is unchanged? The variable name still contains Mario. When the function returns, no matter how hard the function tried to change it, name will still be pointing to Mario. That's what pass by value means. I can pass you a variable as a parameter, and nothing the function can do can change the value in that variable. Note that garbage collection removed the Duke object. Well, that memory that we were using in this function right here, was deleted. That's what happens to old objects when they're no longer used. Now let's look at an object that is mutable. Create a list object. A list is a mutable object, as in mutate or change. When you see mutable, think of mutate. Mutate is to change. You can change the values stored in a mutable object without creating a new object. Here's my list. It contains the values 20, 40, and 50. Now watch how we change the data. I go to mylist subscript 0 and assign it a 30. And a 30 replaced the original 20. When you assign a new value to slot 0 of the list, you can see that the 30 simply replaced the 20. A new object was not created. The data inside the old object was changed. A mutable object allows the data stored in a variable portion to be modified. An immutable object will throw away the old object and create a new one. A mutable object will keep the same object and just alter the data inside of it. mylist.insert 1, 99. The 99 is inserted at index 1. The values 40 and 50 were moved over to make room for the 99. And all of this occurred within the same object. That's why it's called a mutable object. It allows the data stored in the variable portion to be modified. See that 99? It's shoved over the 40 and 50 and inserted into the same object memory. Again, we jump over the function definition to the call to new list, and I passed mylist as a parameter to the function. Call the function newList and pass it the mylist argument. Underneath the covers, same is going to be assigned to mylist. The value of the argument is assigned to the parameter automatically. Pass by reference, aka call by reference. When you pass by reference, you can change the original. The variable mylist can be different. At the start of the call, we contain these 4 numbers. These numbers can be changed when the function returns. Pass by reference says if you pass me a parameter, I can change the data stored in that parameter. Run the function newList with the passed mylist argument. So what's going to happen here is same equals mylist. Well, what does that do? Same equals mylist. It means I want same to point to or refer to the same object as mylist does. I know this is a silly name, same, but it's there for a reason. It is the same object that mylist is. And remember, mylist and same are mutable list object references. Any change will affect the original mylist object. Same and mylist are pointing to the same list object, so any change made to same will be a change that occurs to mylist. I execute same.remove 40, and the 40 disappears out of the object that same is pointing to. But guess what? Mylist is also pointing to that object, so mylist also lost the 40. Use the same object reference to remove the value 40 from the list, but same is pointing to the same object, so 40 is also removed from mylist. Pass by reference, aka call by reference. When you pass by reference, you can change the original. The variable mylist is different. Before the call, it contained 30, 99, 40, and 50. After the call returns, mylist will be different. It will contain 30, 99, and 50 when the function returns. This is because a Python list is mutable and passed by reference. You send a list to a function, it can change the list. An immutable variable is passed by value. If you send an integer as a parameter, it will simply create a new object and your original will stay the same. Simple variable types like int, string, and boolean are immutable. This means when a new value is assigned, it creates a new object rather than changing the data in the old object. This is why they are passed by value. If you pass an integer containing 50 to a function, when it returns from the function, your variable will still contain a 50. More complex variable types like list, dictionary, custom classes are mutable. This means when new values are assigned, it modifies the data in the current object. That's what we mean by pass by reference. You send this object as a parameter to a function. If that function changes its data, your data is changed forever. The get set pattern. A pattern, something that repeats itself. Objects are mega variables. They contain multiple pieces of data. Get and set methods, getters and setters, follow a clear pattern. Set methods put data into objects. Get methods pull data out of objects. Set methods are a way to add new data to an object. Get methods are a way to retrieve the data from an object. We study the pattern because lots of Python built-in classes and objects follow the same pattern. Certain methods will allow you to insert data into Python objects, and certain methods will allow you to extract data from Python objects. Once you spot the pattern, you understand the object. Earlier in this lesson, it was explained. A class is the blueprint or template for creating an object. Let's create a class car here. But you don't need to know all the details about a class to use its object. You just need to know the variables and/or the methods of the object. A class will be composed of a set of variables and a set of methods. And if you've got a good idea what the methods are, you can use that object. You don't have to know the exact details. Google Python objects or Python classes or Python string class, and it'll tell you what you need to build and use an object out of the class. The point I'm trying to make here is you need to know that the class exists so you can build an object. You need to know some of the methods, but that's about the most of the detail you need to know. You don't have to see the source code to use an object. All you need to know is this is my class, and these are the methods you can call to do things with it. As we advance, knowing the methods will become more and more important, but keep in mind those methods are there to set and get values in the object variables. So even if you're just given a list of the methods, understand that there are some variables underneath there that these get and set methods are accessing and modifying. Objects can represent real-world things. A car is a well-known example, but it's also very game-oriented. There's plenty of racing games out there and grand theft games out there. A car is a very well-known object within the gaming world. Understanding class and object design. Variables describe what the object is. Methods describe what the object does. Variables like make, year, and cost describe what a car is. This is the information you want to know when you go to buy a car. This is the information you want to know when you're selecting a car during a video game. Set methods let car objects insert data into the variables. That is what set methods do. Get methods let car objects return data stored in the variables. That is what they do. Get and set methods are the actions the object will perform. It's what an object does. Class design. If I'm designing a brand new class, I start with two lists. The first list is what describes what the object is. Once I understand what the object is, I know what variables I need to declare. The second list I do is what actions will the object do. And the list of actions I want my object to do, well, that's the methods I need to write. Let's start easy. My ride equals none. I'll create an object reference variable with the value none in it. Create a type car object reference variable named myRide. This line of code does not create an object. It just creates a reference variable that will point to or refer to the object. It contains the value none to indicate it does not currently have an object assigned to it. None is a big fat flag that tells you I don't have an object. The next line of code does create an object. MyRide equals car and parentheses after it. This is the car constructor. It creates the object and allocates the variables. We need space for make, year, and cost, and when you build a car object, that's when this variable space gets allocated. Make, year, and cost did not even exist until this object was created. Car is what we call the default constructor, and these values, none, 0, and 0.0, are the default values the car class decided to store in the variables. The equal or assignment operator assigns a value to the reference myride that points to the object created. Myride is a reference to the car object. It points to or refers to it. And that's really what we're assigning after building the car object to the myride variable. Let's use our object. Myride.make equals forward mac equals myride.make. Assign a value to the object variable. Extract the same variable from the object. Assign the value forward to the make variable, and you can see forward showed up in the object. Then pull that same value out of the object and assign it to the variable make. All I did is put something in and pull something out. That's what objects do. You store data in them and you extract that data from them. Notice the no parentheses after .make. We are directly accessing the variable of the object, make. If you do not see parentheses here, you're talking about a variable of the object. Here's a variable of the object. Why do I know it's a variable? No parentheses after make. Now JavaScript and the C# languages, they do allow direct access to object variables. This is kind of normal in JavaScript. Python may or may not allow. A class designer decides if access is allowed. Good object-oriented programming design usually says make the users call a method to do something like this, but there are languages that allow you to directly access the variable, and it's an option in Python. Now these two lines of code do exactly what the previous two lines of code do, but they do it slightly different. They use methods to accomplish the same thing that we did in these two lines of code. Set methods assign values to object variables. The parameter value Honda is passed to the method and then assigned to the variable make. So I went to myride. The dot operator says go inside the reference. Set make was one of the methods, and it took the parameter Honda and changed the make variable for us. What do get methods do? They return values from object variables. The variable make value Honda is returned to the caller and assigned to the variable make. I go to the myride object reference. The dot operator says go inside of it and run this getMake method. The getMake method returns Honda to the caller, and the caller assigns it to the variable make. Now why did I have to show you both ways? Because in Python, it's up to the class designer how they want you to access their object. In some Python classes, you are allowed to directly change the variables, and you do it this way. But other Python classes say you are not allowed to directly change the variables, and instead you must call methods to change the variables or even access the variables. It's important to know both ways of accessing the data stored in an object. Set methods have an input parameter the same type as the variable it is setting, and this pattern holds. Make is a string. This parameter that I send to setMake must be a string variable because we're going to assign it to a string variable inside the object. Get methods have an output or return type that is the same as the variable it is getting. Once again, the pattern holds. GetMake must return a string so we know what kind of variable to assign it to. SetMake has a string input. GetMake has a string output. If they are setting and getting a string variable, this is how they should work. We also have a name pattern. If the variable is called make, we usually call the methods setMake and getMake. Let's do another example with the year variable this time. myride.year equals 2016. Go to the myride reference. The dot says go inside of it, and this time change the year variable. Now how do I know I'm accessing the year variable and not a method? No parentheses. So directly change the year variable, then pull the value out of the year variable and store it to the variable YR. We are putting something into the object, and we are extracting that same piece of data right out of the object. Notice no parentheses after .year. We are directly accessing the variable. Some OOP languages do it this way. JavaScript especially allows you to directly change the values of the variables of the object. C# is the same. Python, it's the class designer's job decide if they want to do this. In Python, you may be able to directly change the value of the variables, but not always. It's generally considered good object-oriented design to make object users call a method instead of directly changing the variables, which is why we have set and get methods. Set methods have an input parameter the same type as the variable it is setting. The pattern holds. This is an integer that we then assign to this integer variable inside the object. Get methods have an output or return type the same as the variable it is getting. Once again, the pattern holds. Get year returns an int. We assign it to an int variable yr. Why am I so concerned about types? Because in Python, when you start mixing up your types, when you start using an int like it's a string or a string like it's an int, you can crash your program. It's always important to understand what the type of a variable is and what the type of a parameter or return value of a function is. Set year has an int input. Get year has an int output. We also have the name pattern. Variable is year. So the methods are called set year and get year. It's always important to name your variables and your methods to match what they do. Once you know the pattern, writing more get and set methods is easy. Code generators can easily write them. One of the advantages of using a set method is they can verify the input. If you call a method to change the year variable, you can put some limits on those values. Cars were generally invented around 1900. You don't see too many 1875 cars out there. So you want to set a lower limit on the year, and you also want to set an upper limit on the year. Could it be the current model year or a couple years out into the future? You don't want a car from the year minus 14, and you don't want a car from the year 40,802. It just doesn't exist either in the past or in the future. A good set method should verify input. Cars have a range of years that you should assign to them. If you pass completely bogus values to set year, it should reject those values. No one should set a car year to minus 14. That's ridiculous. A good set method should verify that the data you're assigning to the object variable is good. Think of objects as mega variables. They can store multiple pieces of information, and set methods put values into, and get methods pull values out of those objects. Follow the pattern. We have an int variable, so we have an int parameter to set year, and we have an int return type from get year. Last one, I promise. myride.cost equals 9499.00. Directly assign to the object variable this value. Once it's stored into this variable, pull it directly back out of the object and assign it to the variable COS. All I did is put a value into the object and pull the value out of the object. Notice no parentheses after .cost. We are directly accessing the variable in this case. Again, JavaScript and C#, those are OOP languages that allow direct access to the variables. In fact, it's common to directly access the variables. With Python, depends on who built the class. Python may allow direct access to the variable if the designer wants it, but Python also may force you to use methods to access your variable, and that's generally considered better object-oriented design. So let's use methods to do the same thing. Go to the myride reference, the dot says go inside the object, and call the setCost method. And what does the setCost method do? It modifies the variable. Basically, we're just using a method to do what we directly did up here. Set methods assign a value to object variables. The parameter value 4,999 was passed to the method and assigned to the cost variable. Get methods return values from object variables. The variable cost value 4999 was returned to the caller and assigned to COS. These two lines of code use methods to basically accomplish the same thing that these two lines of code did. Set methods have an input parameter the same type as the variable it's setting. The pattern holds, cost is a float. Get methods have an output or return type that is the same as the variable it is getting. The pattern holds, it returns a float. Set cost has a float input. Get cost has a float output. That's the pattern. There's also a naming pattern. If the variable is cost, we generally call the method setCost and getCost. It's not hard. An object is a variable that has variables and methods. Sometimes you can directly access the variables like JavaScript and C# do. Python sometimes makes you use get and set methods to change the variable. That's why you have to learn both ways of doing it. Sometimes you can directly change the variables of an object. Sometimes you have to use methods to access and change the variables. Learn the get set pattern. Once you know the pattern, using objects is a simple matter of reading the documentation and finding out what are the variables and or methods of the object. The final slide, game engine objects. Object-oriented programming, OOP. A primary goal of OOP is code reuse, where a programmer starts with classes and objects that someone else wrote and builds their program on top of the provided code. This can lead to rapid development. Since the programmer does not have to write every single line of code, the program can be completed faster. Game engines, things like Unity and Unreal. An engine provides a set of classes so a game programmer can create and customize objects to rapidly build a game. The key is understanding the classes and objects they build. This slide will look at a generic engine and the classes and objects it provides to a game developer. When you use a game engine to develop a new game, you are basically getting a set of classes that you can use to create objects, and those objects will be your game. Game engine objects. First things first, the black box you see here is the outer edge of the screen or monitor. A game played in full screen mode would stretch from edge to edge of the screen, but not all games are full screen and play in a smaller window. So most game engines start with a window class. By the way, top left being 00 and a screen resolution of 800 by 600 are just examples we're going to use in this slide. One of the best things about game engines is they handle all these differences when it comes to screens, operating systems, and platforms. We will use a standard 800 by 600 screen, but a good game engine will handle any screen resolution for you, any screen size for you. The top left corner will be defined as 00 on the screen, x-axis and y-axis, and the bottom right corner will be x-axis 800 and y-axis 600. We'll put code examples displayed here. We'll try and keep the examples in this slide as short as we can. Any objects created in RAM memory will be displayed here. That is the memory that is allocated in RAM to hold the references and object variables. Frame equals window. Frame is a reference variable. It points to or refers to an object. A reference is a small piece of RAM. The object is much larger. Objects have variables. Variables define what the object is. A window can be described by its size and location on the screen. It is typical the values in object variables are zeroed out by default. Objects have methods. Methods define what the object does. A window can change size, change position, change visibility. That's what these methods do. It is typical that the methods operate on the variable values. What these methods do is they modify or alter the variables up here. Every game engine I've ever looked has some sort of window class. It might not be directly called window. They might have some different name for it, but it is an object that controls the window that the game is played in. Methods change variables. Go to the frame reference down here. The dot says go inside this object and run the set size method. Change the size of the window to 600 by 400 and you can see the data shows up in width and height. I've drawn the edge of the window as a dashed line because visible is set to false. The actual window is not displayed yet. So a 600 by 400 window would cover roughly this area on the screen. I used a dashed line for the edge of the window because we haven't actually put the window on the screen yet. Methods change variables. Go to the frame reference. The dot right here says go inside that and run set position. Change the x coordinate to 100 and the y coordinate to 100. Move the top left corner of the window to screen coordinates 100, 100. Note how the 100, 100 moves from the parameters. These values move from the parameters to the actual variables x and y. The dashed line around the edge is because visible is set to false, showing where the window will be displayed when it becomes visible. Bang! Visible set to true. The window pops up on the screen. Frame will have its own XY coordinates now, starting here at 0, 0. These are not the only variables. There'll be more variables. The methods are also simplified here, but I wanted you to see how values in the object directly change the screen. Keep this class and object in mind as we move forward. When items are placed on the screen, we will send it to this frame object. See this code? Frame says go to the reference variable. The dot says go inside of it. Execute set visible. And what does set visible do? Changes the value to true. And that's what forces the window to pop up on the screen. Inside the window, we'll have our own coordinate system starting at 0, 0. And since the size is 600, 400, that'll be the bottom right corner. The player character, or PC, is the main character of the game. It's the Mario and Donkey Kong, the Duke and Duke Nukem. These are not the only variables and methods this class would have. This is very simplified. I'm sure there's an x, y, and width variable in here somewhere. That would be part of the class and object. I don't want to overwhelm you. In a real game engine, these classes have lots of variables and a lot more methods. The game engine provides this class/object that will respond to the keyboard or controller commands. There's a pattern developing here. Do you see it? We create a new object, we set the variables, and then we show it on the window. Look for that when we create this player. Player equals new player. Take the class player and build an object out of it. And what we're going to be doing is calling these methods to set these variables. Player.setNameSlayer. Go to the player reference, go inside the player reference and call setName. SetName will modify the value in the variable. When setting up a player profile, many games offer a choice of characters. To keep it short, I sent a simple hard-coded string. But that string could be used to determine many variables not shown. What is the gender of the player? What are the image files I need? What powers does this player possess? The more vars reminds you that there's a lot more going on in this thing. There could be much more data like graphics displayed on the window stored in the player object. Player.setWeapon to squirt gun. We'll follow the pattern. Go to the object reference, go inside the object reference and call a method. Use the parameters of the method to change the values in the variable. Sending a hard-coded string squirt gun and setting the weapon variable. But object variables can also be references to other objects. In fact, just about everything in a game is an object. If weapon is a separate object, it is much easier to swap weapons out. Object variables can be references to other objects. The more methods down here also reminds us there are a lot more methods like draw this player on the screen that we're not showing. Here's an important point. Pay close attention here. I'm using the frame variable that I created on the previous slide to call setPlayer and add this player to my window frame. Add the player object to the window frame. When the window draws a screen, it will use this reference to call a draw method that will draw a Slayer holding a squirt gun. Object variables can be references to other objects. Everything drawn on the window is an object, and the frame will contain a reference to them all. The frame says, hey, draw this window at this size, at this XY coordinate. Then the frame says, you know what? I have a player character in my variables. Go ahead and draw the player character on the window for me. The final game engine class is called Enemy. This is a non-playing character, NPC, that the player object does battles with. Anything that does damage to the main character is considered an enemy. In a Mario-style game, it could be a barrel or an anvil. Create an enemy object and assign it to the object reference badguy1 with the construction parameters to set the values. I'm doing something slightly different in this slide. When I build the enemy object, I'll send parameters to the constructor like vampire 20 and 10 and use those to initialize the X, Y, and type variable. This is a shortcut. I don't have to call set methods to set these values. But once again, we go back to the frame. We're going to the frame and add this enemy to the list of things I want to draw on my window. Go to the window frame and add bad guy 1 to the list of objects to display. Once there, every time the window is updated, bad guy 1 will execute its draw method. Everything on the window is an object. Each object must contain all the data needed to draw itself on the window. Bad guy 1 is an enemy list for the frame object. It will go and draw it on the screen at its X and Y coordinate. You can see X and Y is 20 and 10, so it goes and draws a vampire at coordinate 20, 10. How do we do movement? Enemy movement is a simple matter of changing the XY values of the object. The call below is too hard-coded for me. In an actual game, each enemy object would have an internal move method called automatically by the engine, just like draw is called. Move would look at the type variable and decide how the object moves. But I'm running out of room, I'm running out of time, I need to shorten this, so I use a hard-coded. If I go to bad guy 1 and tell it to set a new position of 30, 20, the next time the window frame draws this, the vampire will slide over and be drawn at a new position, and that's how video games move objects on the screen. Want more enemy each level of the game? Simply build more objects and add them to the frame. Note each object has its own type, X and Y values. Draw places different images at different locations. Move is also customized for each enemy object. Create a zombie at 305 and a zombie appears at coordinates 300, 5. I'll create a mummy at coordinates 20, 370. So a mummy appears at coordinates 20, 370. All you have to do to accomplish this is to make sure that you add the enemies to the enemy list in the frame class. Frame becomes sort of an umbrella object. Frame represents the window frame, and anything you want to show up on the screen will be put into the window frame and therefore drawn on the window. I cannot stress enough that very, very simplified. Game engines have a lot more classes, a lot more objects, a lot more variables, and a lot more methods. But the concept is the same. Everything is an object. When you want to create a window, it's an object. You want to put something onto that window? Put objects onto that window, and they'll start showing up on the screen. Well, thank you and good night. Holy moly, that was an excellent slide.